Hello everyone, today we're going to be looking at the tool FFUF. FFUF is a web fuzzing tool written in Go. So first we're going to be going over the install of the Go programming language as well as the FFUF tool. Then once we have that out of the way, we're going to be doing content discovery, Vhost Discovery, and then we're going to end it off with some post data fuzzing. So there's going to be time cards in the description for each one of these sections, so go check that out if you're looking for a specific concept. So to get this install started, you want to go to the go.dev link in the description to set up the Go programming language. You want to click the blue download button. Then you want to click the file associated with your operating system. So I'm on Linux, so I'm going to download the tar.gz file. Go ahead and go back to the previous page, and this is actually going to have the instructions on how to install it. So there's different sections per operating system. So if you're on Mac, you follow this one. If you're on Linux, you follow this one. So I'm going to go ahead and copy the install command, and we need to enter a root session. So let's go to the downloads folder where the tar file is, go sudo su to enter a root session, and then we just want to paste that command in. So now that it's installed, it's not going to be bound by default. So if you go ahead and type go, once I exit out go, you can see that it isn't actually installed. So we need to add that line, the export line, into our bash rc. So we want to do vim and then the home directory .bash rc. And you want to go ahead and skip to the bottom. I'm just using uppercase G to go to the very bottom, and you just want to paste that in. So I want to save that. And now we want to actually source it. So we want to do source and then bash rc. That's going to reload the file. We type go, and now it's installed. So with that installed, let's go to the FFUF GitHub repository, and you want to go to the installation section, and you want to copy the actual install command. So you want to paste that in. It's going to take a bit for you, but for me, it finishes instantly because I already have it. And now what we want to do is we want to actually find it. So you can do sudo update db. That's going to update the locate database, and we can do locate FFUF and then grep bin. This is going to show where it's installed. And you just want to go ahead and you want to copy not the FFUF executable, but the actual bin directory. So you want to copy the directory on where it's installed. And once that's done, you want to go ahead and do vim. Same thing as before, bash rc. You want to type uppercase G to skip to the bottom. And you want to say pretty much the same thing as the previous line. You're going to say export path all uppercase equals $path. And you want to do colon, and then you want to paste that directory. So go ahead and then save that and exit. And if we actually source it again one more time, we finally have it installed. So if you go ahead and run the binary FFUF, you can see it prints how, if you pass no arguments, it shows you all the arguments listing. So it says fuzz faster than you fool, and that's how it's installed. So let's move on to directory brute forcing. We can go ahead and get this started by using the FFUF command, FFUF, and then we can say -w for word list. In this case, I'm just going to be using a standard seclist list. I'm going to use seclist discovery web content big.txt. Then we want to go ahead and we want to pass the URL using the -u option. In this case, I'm using a hack the box machine, so I'm going to go ahead and grab that IP address real quick. Then I'm going to specify the port, and then we want to do another /. Now, before you press enter, we do have to put the fuzz keyword. So what the fuzz keyword does is it's going to take each line of our word list, and what it's going to do is it's going to put each one of these lines, and it's going to replace that fuzz keyword. So I printed out the content over here to give you a little example. I'm going to take that line for each line, and it's going to put it at the end. And this is really nice because we can put this fuzz keyword anywhere in the string. So we could do /fuzz/login to maybe enumerate directories before the login directory, or even after. We can say /login /fuzz/auth, and it's going to enumerate all directories in the middle there. So I'm going to go ahead and just use the root directory here. I'm just going to use /fuzz to enumerate all the root directories and files. I'm going to go ahead and press enter. So you can see some files are coming in. We have ht_access and ht_password_d. These have the same status, the same size, and the same word and line count. So it's probably the same 403 page, right? And so you can see some 301s coming in. I believe that's moved. So we have the CSS directory, we have the fonts directory, and we have the, images directory and the JS directory. Pretty standard stuff, right? So something you can look at is two things. You can see the matcher query at the top. So what matcher is these are all the status codes that indicate a positive response. So if we send a web request and the web request sends these responses back, we're going to catalog it and we're going to print it out to the user. Another thing you can notice is the requests per second. It's pretty high, 555 requests per second. This is a pretty fast machine. Let's say we're working on an industrial system or something that doesn't have a lot of bandwidth. It doesn't have it's not able to take these requests so quick. We want to limit that. Well, we can do that as well. So I'm going to show you how to limit the rate of the request along with the matcher query. So for example, let's say we only want to show requests that respond with the status code 200 through 299 and additionally 403 requests. We can do that. So I'm going to press the up arrow and then I'm going to use the -MC to set the matcher options. We can use a range here. So I'm going to say 200 to 229, comma 403. So that's going to specify the OK status codes along with any 403 errors for forbidden. Then to rate limit it, we can use the -rate option. So I'm doing -rate 200 to limit it to around 200 requests per second. You can see the matcher query changed, right? It's now saying 200 through 229, comma 403. And if you look at the requests per second, you can see it's around 140 to 130. So it did slow down the requests a lot. Oh, there we go. Now it's at around 200. I'm going to let it run for a bit just to show you it's not going to print anything else out besides the 403 requests. All right, so it's done, and you can see nothing else printed out besides those 403 requests, which is nice. Let's say instead of only showing 403 requests, we want to use all the default matcher queries that it provided, and we just want to filter out 403s. We can do that as well. So if we go ahead and press up arrow and delete all of our previous queries, we can use the -FC option and then the status code to say, hey, only filter out this range or this singular status code. So in this case, I'm doing -FC 403. And you can see the HT access and HT password D, they weren't printed out to the screen. And if we wait a little bit, you can see the CSS directory, which resolves into 301, as long with the fonts, images, and JavaScript directories. So it's done. Let's say we can also do some file enumeration. So let's say we want to append an extension to each one of the words on our word list. We can do that as well. So let's say, for example, I'm going to be using the same file, but let's say this is just a list of file names and we wanted to append an extension to it or multiple extensions. We can do that as well. So I'm going to press up arrow and I'm going to get rid of our previous query. I'm going to use the -E option to specify extensions. In this case, I'm going to do .php, .xml. And you can see it starts checking for those specific files. I'm going to let this run for a bit because this scan actually does enumerate more information. So you can see after some time here, it did find a bunch of different new files, right? Obviously, this would be more effective if I chose a word list of just possible file names without the extensions, but you get the point, right? Very useful for just checking for the existence of files. So I'm going to go ahead and stop the scan for now so we can move on to the next option. And let's say we want to enable recursion, right? So let's say instead we're scanning for directories again, and we want it so whenever it finds a new directory to then also scan that directory. We can do that as well with -recursion. I'm going to go ahead and press enter to get that started. And for every new directory, it's going to add to the queue the next directory to scan. So go ahead and let it scan for a bit. You can see it finds that CSS directory and then it says info, adding new job to the queue, and then it prints out the new fuzz string it's going to be using in the next job. So you can see it's doing that for the fonts directory, the image directory, as well as the JS directory. So this is pretty useful if we want to scan all the directories on this website. We can just use the -recursion option. And for this case, on this box, it really doesn't enumerate anything too interesting. So I'm going to go ahead and cancel out of the scan. And now let's say we want to output this. So the standard outputting that FFUF uses is JSON. So we can use -O. I'm going to just say hackthebox.json. And if we go ahead and press enter, you can see it's still printing out to the screen here. But if we give it some time and just cancel out of the scan, let's go ahead and cat the JSON file that it created. And it's pretty ugly. So I'm going to go ahead and copy all of this and put it into a JSON formatter so we can get a better look at it. So I'm going to copy it. Just go to Google real quick and look up JSON formatter. Click the process button. Click the process button here. And you can see it prints out a bunch of nice information. So it tells us the command line used, the time that the request was started or the command was started. And then it gives you an array, a JSON array of each fuzzing keyword, along with the position of it on the word list, the status, the status code returned, the content size, and the words, pretty much the same as the previous output. But let's say we do just want to output it to a standard text file. For this, we can just use standard redirection. So I'm going to go ahead and press up arrow a couple times. I'm just going to use greater sign hackthebox.txt. What's nice is this still shows the status, so it still shows you the progress of the scan. But after we let this run for a bit and we use Control C, you're going to be able to see that it is outputting it to a text file. So I went ahead and canceled it, and if we cat out the if we cat out the hack the box file, you can see that all of the information is saved in here. So now let's go ahead and move on to vhost enumeration. So before we actually get into the brute forcing, I want to do a quick definition of terms. There's 3 different types of virtual hosts. So the first one is IP based, where each host name of the website is hosted on a different IP address. So for example, if we had admin.hospital.com, that would resolve to one IP address. And if we had hospital.com, that would resolve to a different one. Then there's name-based virtual hosting. So for example, in the same example, if we have those 2 different endpoints, admin and then normal hospital.com, if you went to either one of those in your browser, it would resolve to the same IP address, but the content would change depending on what hostname you entered. So if you entered admin.hospital.com, it would take you to the admin page. And if you just entered hospital.com in, it would just take you to the generic hospital website. So dynamic virtual hosting is very similar to name-based virtual hosting in that it allows multiple websites to be hosted on a singular server. However, the dynamic is much more flexible because it utilizes patterns or rules to determine map requests to the respective directories. So this means you don't have to manually specify the relationship between each domain name and its directory. The server automatically figures it out based on the patterns that you established. So it's a lot more flexible, where name-based is very explicit with the configuration, but both dynamic and name-based both utilize one IP address. So I have a different lab pulled up here. This one's pov.hackthebox. This is where we're going to be doing our vhost enumeration. So let's go over to our terminal, and we're just going to do FFUF-W for the word list once again. And like always, there's a sec list for it. So we're going to do sec list, discovery, DNS. And the one I'm going to be using is subdomains top 1 million and the shorthand version, so only 5,000. Then we want to pass the URL. So in this case, we're actually going to be passing the IP address. So I'm going to go ahead and go over to the browser and grab that real quick. Then we want to use -h, and we're going to say host, and then we're going to say the fuzz keyword again. So host : and then we're going to do fuzz. And just like before, it's going to take each one of these lines in our word list. I'll go ahead and print it out over here. It's going to take each one of these lines, and it's going to put it there. So it's going to put fuzz there, or it's going to replace fuzz with those words. So fuzz dot, and then we want to pass the domain name. So pov.hackthebox. And just like before, we can put that anywhere. So you can see it spat out a lot of information. This is all, they're all the same file size, right? So we want to actually filter this out. These are just redirecting back to the home page. We want to copy that and we're going to say, hey, filter out all pages that return this file size. So let's go ahead and press enter. You can see now we only have one result, right? And it's dev. So I'm going to go ahead and let this finish, and then we can go ahead and pop this into our browser. All right, it's done. Let's go ahead and open this up. So we're going to go to dev.pov.hackthebox. And you can see it's a different website, right? So if we can go back, completely different websites. So now that that's done, let's go ahead and look into post parameter enumeration. So I went ahead and set up a little fake web storefront here using Django, and it's just this one singular page that's used to sell spam. And if you look at the bottom left, you can see it says add coupon code. So let's go ahead and put an invalid coupon in there. You can see it says invalid coupon code. So let's inspect. Let's go to network traffic, and let's see what it's doing here. So if we do the same thing as before, buy item, you can see we get a request here. So it's a request to the endpoint validate coupon. It's a post request that passes that code we provided. And the response we get back is a 400, meaning that it didn't work, or technically it's a bad request. So let's go ahead and see what happens if we pass a valid coupon. So I'm going to scroll back down here, and I'm going to pass one that I already created. So 8001. I'm going to click buy item. You can see it's the same post request to the same endpoint. Obviously the code and the post parameter changed, but this time we get a 200 response back. So meaning it worked. So let's go ahead and brute force this by making a word list in sec, and then passing that with a FFUF. So let's go ahead and make this a little bigger here, and let's say sec. Then we're going to say -w 4 zeros to 4 nines. So generate a word list in this range, and we're going to output it to codes.txt. So once that's done, we can then use FFUF to actually import it. So we're going to clear the screen here. We're going to say FFUF -w and then codes.txt, that word list we made. We're going to use -x post to specify it's going to be a post request, -d to specify the data we want to specify. So in this case, we're doing code equals fuzz, where it's going to take each code in the codes.txt and replace that line with, or replace the fuzz keyword with that line. And then finally, we need to specify the headers. So let's go back in the browser. Let's go ahead and let's go to the network section. Let's send a request over. And if we click it and we go to the request headers, you can see the content type is application www form URL and code. So let's copy the value and we're going to say -h and then we're going to say content -type and colon, and then we want to paste that header. Then we want to specify the URL. So we want to do the localhost address because it's running on my local host. And then we want to say validate underscore coupon. So let's go ahead and let this run. And you can see it's already finding some, but I'm going to let this run and then I'll see you guys when it's done. All right, it's done. You can see it found a bunch of codes here. Let's go ahead and try some of them out. So I'm going to go back into my browser. I'm going to paste the coupon code in. I'm going to click validate or buy item. And you can see that one worked. Let's try another one. Let's try 4444. Paste that one in. You can see that one works. That one works as well. So hope you guys enjoyed. This was a video going over FFUF, and I'll see you guys in the next video.